Hey, in this video, I'm going to teach you 5 key concepts with practice problems that will help you ace your next calculus exam. So let's begin. The first question is, f of x is equal to two functions under two conditions. So basically just a piecewise function. So let f be the function defined above. Which of the following statements about f are true? So this is a very common question that you have to identify each statement and you either plug the numbers in or think about it conceptually or graphically. That will help you to do this type of questions. So the first condition is given us as f has a limit at x equal to 2. So we can first simplify the top expression first. I think that will make the whole thing much clearer. So f of x will become x minus 2 times x plus 2 divided by x minus 2. So then x minus 2 just cancel out, so the whole expression just becomes x plus 2. So then we know that limit as x approaches 2 of f of x is equal to limit as x approaches 2 of x plus 2, right? So it equal to 4. So then the condition 1, we tested it out, is true because there is a limit at x equal to 2. Okay, so let's continue. The second condition is f is continuous at x equal to 2. Okay, so is this correct? Well, we're given us that, sorry, this is a 1, this is a concave 1. So f of x is so when x is equal to 2, f of 2 is equal to 1, right? So what are the conditions that for a function has to be continuous have to met? Well, it has to have like f of x equal to c, then this constant is also the same number with the limit of that function approaching that x value, right? So in this question, it clears not, like it clearly is not. So then f of 2 is 1, which is not equal to 4. So that means that second condition does not met. And we'll look at the third condition, which f is differentiable at x equal to 2. Well, if you want a function to be differentiable, the first condition you have to met is that this function has to be continuous. So because the second condition, we test it out and find out that it's not continuous function, so then the third condition cannot be met. Okay, so the only answer will be the first condition is correct. Okay, I hope it explains clear enough. And then the second question is, a particle moves along the x-axis with velocity given v of t is equal to 3t squared plus 6t for time t is greater than or equal to 0. So if the particle is at position like x equal to 2 at t equal to 0, then what's the position of the particle at t equal to 1? Okay, so this is a very common position, velocity, and acceleration question. So in this case, we have to know like the relationship between position, velocity, and acceleration. So we know that velocity is the derivative of position, and acceleration is the derivative of velocity. So after we find out this relationship, then we can then the whole question will be a lot more clear. It asks for the position of the particle, which means it asks for the s of t, right? So basically s of 1, but we have to find s of t before we find s of 1. So s of t, we can just simply taking the integral, because the kind of the opposite operation for derivative is taking integral of that. So we can take the integral of v of t. But what's the bound, like the upper and lower bound? Well, because we know that it asks us for the time when t is equal to 1. Yeah, so when the time is equal to 1, then we basically starting from 0 to 1, right? Because time cannot be negative, so we have to start from 0. So we just take v of t dt. And there's a very important thing that cannot be forget, is that the initial condition. What's the initial condition for this question? So it says x is equal to 2 at t is equal to 0, which means the starting position of this particle is at 2, right? So we have to add 2 in order to find the real position of this particle at t equal to 1. So we can just simply do all of this by hand. So s of 1 is equal to s of 0, which is 2, we already find it, plus integral 0 from 0 to 1 dt. It's equal to 2 plus 0 to 1, 3t squared. So I think, like, in order to do this integral, the fastest way, I think, is to separate these out. So separate the whole integral into 2 separate integrals, which will become this. Okay, so then we can just take the integrals for each one separately. 2 plus, so remember 3 times t to the third power divided by 3, and from 1 to 0, but yeah, in here. So yeah, so we can divide the constant out, not divide actually, but just pull the constant out of the integral. So basically move this 3 out in front. And the same thing for 6, which I think will be a lot simpler. And the other thing is just the same. So yeah, so after you're in this step, then all you need to do is plug the 1 into the things and plug in 0 to the whole thing. Okay, so I'll show you. Okay, so this will becomes 2 plus 1 plus 3, which will be 6. Okay, so we find out the final position of this particle at time equal to t. No, time equal to 1, I'm sorry. Okay, so yeah, so let's keep going. Okay, so the next question is, we're given that f of x is equal to cosine of 3x. Then we're asking to find f prime of pi divided by 9 is equal to what? Okay, so first of all, same thing, we can start by taking the derivative of f of x, which we can do this. So f prime of x will be, so cosine of 3x. So when you're taking the derivative of cosine, it will becomes negative sign. So negative sine 3x. Don't forget chain rule to times 3. So this will becomes negative 3 times sine of 3x. And if you plug the pi divided by 9 into this whole thing, then f prime when x is equal to pi over 9 will become negative 3 times sine of 3 times pi over 9, which will become negative 3 times sine of pi over 3. Okay, so pi over 3. Remember the unit circle? The pi over 3 will be a 60-degree angle, which has x component of 1 over 2, y component of root 3 over 2. So then sine will be root 3 over 2 in here. So which will become negative 3 times root 3 over 2. The whole thing will become negative 3 root 3 over 2. Okay, this is our final answer for this question. Okay, let's keep going. So 2 more questions. Yeah, another question will be a graph. So forgive my rough sketch, but I just want to show you like how this question will be like. So this is here. Okay, so this is what we're given as a graph. So the question says the graph of the piecewise linear function f is shown in the figure above. So this is the graph of f. And it says if g of x is equal to integral from -2 to x f of t dt, which of the following is the greatest? So there's a couple choices. So first, like choice A is g of -3, and then it's g of -2, g of 0, g of 1, and g of 2. Okay, so it asks us to find the value that is greatest. So we first, like this equation gives us a lot of information. We know that g of x is equal to f of t from -2 to x. So what does it tell us? Well, f of t, we already know this is the graph shown on the left. When you're taking the derivative of a function that is already given to you, a quickest way to know is that it basically asking you to find the area under the curve. So which means that g of x in this case is the graph of f of t from -2 to x, the whole area under those like the curve from -2 to x, like those intervals, the areas under the curve. So which means that we're starting from here, -2, right? So we want to find the area. So remember that area, like if you want to maximize your area, the first the key thing is to find the first zero, like the first intersection of the graph with the x-axis. So this is our x-axis. So at which point is f, like first cross with f of x? Well, it will be when x is equal to 1, right? So you can see that this whole area is all about is all above x-axis, which means that it has the greatest area, because if you continue going this way, then the area will become negative. Like this part will become a negative area, like this will be negative, which means that when you want to find the total area, you have to subtract whatever this area you want, like you go like continue going. So we don't want that, because the question is asking for the greatest area, so greatest value. So it means that it means the answer should be g of 1, right? Because this is the first intersection of the f crossing with x-axis, which is the positive areas that we want to find. Okay, so one more question. So same thing, this is also like a rough sketch. Okay, so this question says the graph of the function f. So this is the graph of f. So okay, so this is f. It's shown for like it's shown to the left with domains from 0 to 3, like closed intervals. It says of the following which has the least value. So I will just like read out the each choices for you, and I'll like write it out like simply, but I may not write the whole thing, but I just wanted to show you how to do this type of questions. So the choice A will be from 1 to 3 integral f of x dx. B is left Riemann sum approximation of 1 to 3 f of x dx with 4 like subintervals of equal length. C will be right Riemann sum, and all the other conditions are the same. And D is the midpoint Riemann sum, and all the other conditions are the same. E is the trapezoidal sum. All the others are the same. Okay, so for this type of questions, I think like I know some high schools or like whatever your teacher or professor would told you some like some things want you to memorize to looking at different graphs, like for example this graph is decreasing, so if you're using like a right Riemann sum, then it will become a underestimation, and if it's like a left Riemann sum, then it will be an overestimation. Well, this is good, but you know, like when you're taking a test, like it's not working for me at least. I have a hard time to memorize all of these things. So what I would do is I will basically like pick up my pencil on the test, and I will try to do the Riemann sum, like different Riemann sums, and like midpoint or trapezoidal sum approximations. So I'll show you right now. So first of all, we can do the left Riemann sum. So left Riemann sum just means that like the left point is where you the left of the each rectangle is where you touch the curve. So it will be like this. Okay. So after you draw this, you can clearly see that this must be a overestimation, right? Because all of these areas are not what we want, are not like in exactly on the curve. So if we want to test it out using a right Riemann sum, then it will be like this. It's where the left side of the rectangle touches the curve. So you can see that this must be an underestimation because all of these areas are like under the curve. These areas we didn't account to it. So which means that using a right Riemann sum must be an underestimation, and left Riemann sum must be an overestimation. So the question is asking us which has the least value, which means that we want the approximation with the most underestimation. It's kind of like I'm saying the sentence a little bit backward, but you get what I mean, right? So we already know that right Riemann sum has the underestimation. So we don't even have to test out the midpoint or the trapezoidal sum, because midpoint or trapezoidal always has more exact value when you testing the area of a curve, right? Left and right Riemann sum are always the two extreme values. That's how I memorize all of these. So if you already know that right Riemann sum gives you the underestimation, then there won't be another approximation that is like even has the least like more like lower value than the right Riemann sum. So that means that the answer given us will be C. Because the right Riemann sum is the underestimation, which is what the question is asking for. We want the least value of this area of the function f. Okay, Okay, so here are 5 questions. I think those are core concepts and topics that covers for Calculus 2 exam. So I hope you learned something from this video. And if you like, please subscribe or leave some comments below. And thank you.